Welcome to our session from discovery to defense, staying ahead of threat actors. I've got two incredible human beings with me today, Andrew Grealy, Michael Freeman, heads of threat intelligence at Armis. I'll be your host, Thomas Poor. I am the director of sales engineering with Pantera. And let's take a moment to get to know these guys. So Andrew, why don't you start?
Yeah, excited to be here. Thanks for the invite. Yeah, we're here to talk about how we get in front of threat actors, right? It's a really hard problem to solve, and that's how we built the company. We built this company called CTCI, Cyber Threat Cognitive Intelligence, and recently we were acquired by Armis in February. So yeah, excited to talk about how we got there, what do we do, and how it can take advantage, how CISOs and organizations can get ahead of threat actors.
Awesome. All right. Michael, would you take a moment, introduce yourself?
Yeah, my name is Michael Freeman. I spent a couple of decades building offensive and defensive capabilities for different U.S. intelligence agencies. Left that space to go work for Nike, where I built a lot of infrastructure and different components there for helping the organization mature very quickly in the security operations space, which where I met Andrew. Long story short, we'll go through some of the details, and we end up starting a company together, which got acquired recently from Armis.
All right, that's awesome. So you guys met at Nike. So I'd love for you guys to take a moment and sort of unpack your founder's journey and how did it come to be? I don't know if you want to kick that off, Andrew.
Yeah, sure. So my job was in the cyber threat analytics. So my job's like going through 40 odd terabytes of data and finding the bad stuff. And through that bad stuff, we get all these threat intelligence feeds, lots of threat intelligence feeds. And when as a data scientist, I found we're having 900 to 1 false positive. So I'm like, turn all these feeds off, except we had one feed that came in, and I went to the head of threat intelligence. I said, what company is this feed? And they said, no, that's not a feed. That's a person who works in the team, Michael Freeman. So I met Michael Freeman, and he saved our buns probably 10 to 15 times a year with that early warning threat intelligence. So we decided to have lunch every Friday at Red Robin. Always love the campfire sauce. It's always good on those bottomless fries. And when COVID hit, I love Nike, meet all the athletes. And when COVID hit, I'm like, you can't be on site. You can't meet all the athletes. So we said, and all these hospitals were getting compromised. So we said, well, Michael, you know what they should be doing, getting ahead of these threats. Let's go save people's lives with these hospitals and critical infrastructure. So long story short, we started that company. And we get to play a bigger game, be a part of Armis, and over 1,000 customers in all different sectors around the world, and make sure they become more secure and get early warning in front of the threat actor.
All right. So great perspective. Now, you were talking a little bit about like threat feeds, and you learned, Michael is producing his own threat feed, as a human. So Michael, walk us through that a little bit, and what's your background, and then how are you sourcing that, and your perspective on your founder journey?
Yes, my background is a mixture of building offensive tool sets and capabilities, and developing a lot of really advanced defensive capabilities, and a lot of R&D type of projects for think tanks and intelligence agencies. So I left that space. I did some work for a local hospital up in Oregon, and designing some unique technologies for them. They got hit with a quack bot that took down some extremely critical patient impacted systems. It kind of changed my focus drastically at that point from a very heavy R&D future type of design technologies to, hey, if that technologies or some of those technologies developing were in place now, there was major impact, especially on the field monitoring systems, impacting, babies and stuff like that, because I had just had my youngest one not even 8 months before that. So kind of changed my focus to let's help the companies that really need it now. So I went back to doing some more R&D work for a think tank that was closer to that area. Left that, went to work for Nike. And as Andrew said, when COVID hit, I started helping a group of researchers that got together and were sharing intel to a lot of hospitals around the world, different certs around the world, giving them information that's going to be very helpful. But as we were going through that process, Andrew and I also started sharing the intelligence I was collecting to a lot of our friends that we've known in the industry that are CISOs or, head of SOCs and stuff like that, and they at different companies. And they kept coming back to me and saying, hey, you're saving us from, major breaches. We had a defense contractor. We helped them identify some infrastructure 10 days before they got hit with Blue Key. They didn't even know it was coming down the pipeline. We let them know beforehand. I had another company, a large financial tech firm. We let them know 10 days earlier. There's 10 to 15 days earlier about a node exploitation that was going to happen on some of their software libraries. They got in front of it, came back and said, you're really saving us. So, we decided let's explore the opportunity of actually building a company. We went to a friend of ours who does a lot of investments. He came into town, spent Saturday with us, listened to what we do, quick handshake deal. I don't think we even had a contract in place, and he wired some seed fund money to test it out. We went to Black Hat, talked to some of our friends down there. We literally had a company say we want to buy you with the first hour of looking at what we're doing. It's also a company that does a lot of threat intelligence. They said, you know what, it cost us $10 million a year with 200 and some people to do just a fraction of what you do, and your data is much more accurate and more timely, which is a key component, the more timely aspect of things. And we didn't even have a company at this time. So our investor helped us stand up the company, and basically said, go forth and figure this all out. And that's how we got started.
Yeah, it's an amazing journey. So as you start to grow, right? I think, help me better understand, like, how does your threat intel help the organizations now? Like, how does it help them like effectively scope their attack surface, and maybe unpack that for me?
So one thing I noticed is at Nike, we had the ability to buy quite a bit of different threat intelligence feeds. And I was looking at it and saying, this is just a really large data set of bad domains, bad IPs, and bad hashes. And Andrew's telling me it's not as valuable as it really needs to be. At the same time, I was taking a look at the vulnerability management team, and they were telling me, we've got 28 million vulnerabilities in our environment. We haven't deduplicated it. A little over 6 million criticals and highs. How do we get in front of this? And I said, you know what? The most important intelligence I was finding, talking to internal customers from the VM team to Andrew's team and a couple other teams, that if we knew what new tactics and techniques were being used as they're being developed or being used, as well as what vulnerabilities are being exploited in the wild or trying to be weaponized by threat actors, that type of intelligence is not something we're able to buy on the market. But it's a lot more valuable when you provide it in a very timely fashion, in a relevant fashion to the environment. Threat actors are constantly working on this, but when we take it from a defender's perspective and take that information, we can go from a very reactive process that we've all been doing for decades to more proactive and getting in front of what the threat actors are doing, cut them off before they can actually do it in the environment. You get a much better return on value on that, and it's a much more better place to play from a security perspective. We're not always on the defense. You can be more on the offensive side, the more proactive side. And that's what we looked at as the intelligence, and the way we got the intelligence was being built. The value was really showing itself. And when Andrew and I were talking about how can we play this in a bigger game, make it more relevant to our customers and to the market itself, we took a look at a couple other companies that were trying to acquire us. And Armis really stood out because they had something that Andrew and I looked at and said, you know what, the key things for all defenders, if you don't know what assets you have, you can't defend against any type of attacks that's coming in. And one thing is Armis is really great at is telling you all the type of assets you have and the context you have it in, and having this intelligence coming in and really helping, especially the vulnerability management team and the security operations team, is a huge benefit. It gets you much further down the maturity level and understanding, if you know the context of your infrastructure that you have, you know what to defend against. And having our intelligence helps you really defend against that.
Yeah, I think
if I could jump in for a second.
Absolutely, yeah.
So a lot of people, like, CVSS score has been around for a long time, right? Everyone knows how to do it. There's 3, there's 4 come out now. And the problem is it's been a proxy for risk, even though MITRE says don't use it for risk, right? It's a vendor's view of the world, and then you add your environmental score. And the thing about threat actors, they don't care about CVSS scores, right? So we spend all the time on criticals in our list of what threat actors are exploiting. It's mainly medium and high, right? About 8% critical, right? So if you think of that, we're patching the wrong things. We're patching just because it's can be exploited doesn't mean threat actors are doing that, right? And there's even some groups out there, like in North Korean group, that go after CVS scores below 7 because EPSS and other scoring don't work below that. So for us, it's a lot of organizations, when it comes to vulnerability intelligence, look at every tweet and every CVE and they try to boil the ocean, 265,000 CVEs, right? Whereas the way we look at the problem, if we follow the threat actors, we follow what they focus on and what they do. And Mike can talk in this in detail, how we use AI and how we get there. Like it's an amazing journey how we do that. But if you follow what the threat actors are focusing on, then you follow the golden nugget, what they're going to do. And for us, like, I don't know if you know CISA Kev. CISA, fantastic organization. We love them. They create the known exploit vulnerability list, the Kev list, but that's known exploited. And having been in incidents lots of times in my life, 22 years in banks, right? I've been in lots of incidents. It's always on a weekend, right? You're always on holidays. Log4Shell, which we got 2 months earlier, was on the Christmas time, right? So if you can get ahead of that. So our view is there. If we match our stuff to CISA Kev, we're getting over about half of those entries about 300 days earlier. So think about you as an organization being able to get ahead of that, patch in an adequate fashion, and put that in your process, and then not be on the page the next day saying, "Oh, we've got to spin everyone up. This threat's out there. We need to work all weekend. We need to see if we're being compromised," right? So being that left of boom, we think is critical for the future, and that's that proactive versus reactive, right?
Absolutely, yeah. I think you both did a really good job of touching on that, right? And I think we still see it today. A lot of organizations still have that like reactive mindset, right? And they're still working through those lists of thousands, if not millions, of vulnerabilities, right? And they're starting with their 10s, and they may not even be exploitable, right? There may no exploit exists, right? So I think Andrew, you highlighted the key differences and shifting that mindset to a proactive defense. So that was fantastic.
Yeah, the other part there is, I like to say, is that it's not just the CVEs, it's also the TTPs, right? We have the TTP feed, which says, hey, this is what we're doing. And I'd like to say people like CISOs and different people in charge of SOCs today, everyone's trying to make that whole MITRE attack framework green. And all those resources to make everything green. Do we have a detection for this? The threat actors are mainly using create, process, and execute, right? Mostly, right? It has to run on the machine, right? And they're mostly doing living off the land. So if you focus on that firstly, and then if you have some resources, go for other ones and other TTPs we're seeing, or match our list with their environment and see which TTPs they're using from that list from a MITRE attack framework, that will put you in a very good position. And also, if you take what we have from this data and match it with your environment, you can see if you spent too much on controls that aren't blocking that sort of attack, right? So it's a good way to say, hey, am I spending the right money in the right security products, the right security architecture? For example right, I'll give you an example, VMware. Like most of the attacks on VMware are a URL, right? We see. So if you put a WAF in front of your ESX console, you should do that today, because we've seen 12 of those vulnerabilities.
Yeah.
And if you just say Imperva or whatever WAF you want, right? Not focusing Akamai, whichever WAF you have or want to put in front, then you say only use the known URLs that you have, you will stop that continual every year. We have those ones compromising all the consoles, right? So
alternative mitigating controls, right?
Exactly. And that puts you, because what we find in our list is once it's compromised once, you see then a repeating fashion, new variation, they work out a new way, because once they've already built it, the threat actors built it in their into their threat chain, they're going to do it again and again. Oh, this one again, just add it in there. Like you see Mariah and them, they just add more and more exploits in there, right? And we're seeing more and more weaponized exploits. So if you see those like Mariah, where it only detects like 65% of the time of protecting it, the trick for us is giving you what is the weaponized exploits they're using. So even if it's running on your machine, it's not going to do the work because you've patched for those exploits.
Right. Yeah. So I think, if you're able to summarize a little bit about how you guys, prioritize and manage the critical exposures in complex enterprise environments, I think you touched on some key points, but if you just want to tie all that together, that'd be great.
Yeah, I think one way to do that is talk about how we get the data. And then once you understand how we get that data, then we'll apply that for that complex, because that gives you then a perspective of what does that process look like, and then how to apply that, right? So
okay, gotcha.
Think through that.
Yeah, and so because I think what you want to highlight here, Mike, is the difference between what some of the vulnerability management solutions are trying to do, right, with CVE, and trying to assess what is the exploitability
Sure.
and probability, right? And so they're trying to use a little bit of algorithms, but we know that there's still challenges, and you guys have an approach, and I'd love to unpack that a little bit.
Yeah. So instead of trying to predict what's going to happen, which if you have enough data about a specific type of a topic, you can definitely come up with a high probability of an outcome that will be most likely. Doesn't mean it's actually going to happen. Problem is, you take a look at those type of scoring algorithms. You take a look at Apple, for example. Apple gives a barest minimum of information in their CVE scores whenever I don't even put a CVE score, they just put their data in there a little bit. And then they create a special web page specifically for that with very little context behind the actual vulnerability. A algorithm with very little information about that particular vulnerability on that, maybe that Safari or whatever the case may be, or specific library, cannot come up with enough information to make a highly likely outcome scenario. Even though a threat actor might actually be exploiting it, if there's no context being added into that algorithm at that time, you're going to have an outcome on that algorithm that says likelihood very, very low, even though it might be exploited in the wild. So instead of trying to predict what might actually happen, we actually target the humans behind the scenes, understand, get attribution on the threat actors themselves, understand what motivates them. And we look at the way they process everything, the way they run their operations. And they're humans too, they make mistakes. And we take a look at their operational security, find flaws in the way they operate. And what we have is some AI intelligence collection components that we have built that is based on cognitive reasoning AI. So we understand the context of a conversation in over 200 different languages that we trained it on. So if you have a Farsi speaking threat actor, for example, talking to another person, trying to weaponize a Windows vulnerability, whether it's a known vulnerability or unknown vulnerability, and trying to land EIP on their exploit, we know that's more actionable intelligence than 200 people on Twitter retweeting the same article. And so we have 3 separate components that we've built to help us collect this type of information for us. The AI intelligence collectors help us identify new sources, rank and categorize the sources based upon the Admiralty score that NATO countries uses for ranking and categorizing sources of the quality of intelligence. So if we have a new source that, whether it be on Telegram, VX channel, it doesn't matter. It'll pull that information and then look and analyze that for us. If it's a high quality source, a human will take a look at it, look at the operations that they're doing, put additional AI intelligence collectors in place. And then as this information is coming in, it flags it for us and says, this is a new source, whether it's a new CVE they're working on or a new vulnerability that they've found the potential zero day that they're working on. At that point, what we'll do is we'll put up take that intelligence and we'll build, and we have these deception technologies I previously created for a project for DARPA. And essentially what these are Haskell-like virtual machines, and we can make them look like anything you want. It doesn't matter, we can make it look like that. But we don't spread them all over the internet, hoping they're gonna get compromised, or put them in customer environments thinking that, threat actors might actually nmap these type of things. But what we do is the intelligence tells us what geographic areas, business verticals, and technology stacks we should put them out there to make them look like that type of environment for them. And you actually have to burn a 0-day and actual exploit to compromise these things. Password spraying and misconfiguration bugs are not going to work against these. because we have two separate AI components on the back end. One specifically looking for known CV exploits, and the other one's known CWE exploits. So a CWE component is maybe it's a 0-day, we don't have a CV attached for it. We catch that type of an attack happen against that. What we do once we have that information or intelligence that we need to actually go through the process and actually create a vulnerability or exploit, for example, we have a separate research phase. And Patch Tuesday was this week. I'll give you an example how this piece works on that. Every patch that comes out, we run it through a patch diff process to see what was changed. Once we identify what was changed, it runs it through a mathematical process and a tool set called a SAT solver. And what this does is maps out all the potential code paths, that vulnerable piece of code that threat actors would have to reach. Once that's mapped out and by the SAT solver, it actually runs it through an automatic exploit generation toolkit to create actual POC. Once we have that POC, we put it back in our deception tools to see if someone's used that in the past. If not, we have detections built on the fly for it. But we also put that back in our intelligence collections piece to see if threat actors actually work on that also. But we have, multiple different types of tool sets on this research phase. Say, for example, we have the customer that tells us, here's all the critical libraries that we use in our environment. Let us know if somebody's trying to weaponize or run an exploit for this. We have tool sets that look for all the POCs published on that, validates they actually work and they're not backdoored. But we look at how many comments are there, what kind of comments are being placed on there, pull request, how many forks, how many watchers, things like that, and identifies, if there's a potential vulnerability that might be critical. This is how we got Log4j's vulnerability 2 months early, for example. So these 3 separate processes, even though they're separate, do push and drive each other. If we have new intel coming in, we do the research and verify, yeah, this is going to be a bad one. Threat actors are definitely trying to weaponize this bad CVE. We have detection or deception capabilities pushed out there, but we'll let our customers know early. Say, hey, this is something we know for a fact. It's a A1 level type of source. Threat actors are working on it. Go ahead and patch this, get in front of it before they actually get the exploits to work.
So if I summarize in probably 2 sentences, right?
Yeah.
Instead of prediction, we see it with our own eyes, right? And that's a big difference compared to prediction. I've written a whole paper, 19-page paper on data science of EPSS versus what we do and that sort of stuff, so people can understand in more detail from that part. And then once you know that with your own eyes, you know it to be true, then organizations can use that actionable information to put mitigations or patching or remediation early in that whole process. And that gets you ahead of it, right? So that's the whole point of that. So, and if you take the attack surface management, which you said, if you take that, like a product like Armis, where you see the attack surface, then you know where your weaknesses are, and then you use that as a major prioritization. And you look at other security findings too, like misconfigurations and that as well. But you use that as your North Star of saying, well, if it's external facing, if it's a crown jewel and it's got a vulnerability on it in that list, then do something about it today.
Yeah. So I think great summary. Let's dig in a little bit to like that, the asset discovery for a second, right? So, Armis, well known for asset discovery, identifying the attack surface. How have you guys seen your threat intelligence, make an impact on the security posture of an asset?
Oh yeah. So there's probably 3 major use cases, I think, right? The first is, you go to sites like Bleeping Computer and those, and there's something in the paper that says, you need to do this right now. And people go and check in our list to say, I'm not going to do that right now, right? These are things that are more important, right? So being able to take between information and misinformation becomes really helpful in this day and age, right? That's the first case, right? The second case is one of the top 3 of, YL Ventures did a view of 400 CISOs and said, what's your top of 3? And the top of 3 became all of them. All of them had vulnerability prioritization, right? What should I do right now, right? And that's where we see 60% of all companies are compromised from known vulnerabilities. They know about it, but it's just a fire hose, right? Of what should I do? And if it's 2 lines of text, are you going to drop everything? What are you going to do right now? Right. So it's saying, hey, where do we get that intelligence? So then that's the next part, the vulnerability prioritization to say, with my assets, where should I focus most of my time and effort, right? And for example is, you know, if you've got Active Directory talking to every asset in your environment, you've got a map of everything goes back to AD, and you have an AD vulnerability, right? So if you have that, it's like that would be protecting your crown jewels. That would be, you know, high on the order for mitigation and those sort of things, right? So, and the other part there is when you've got the asset intelligence and you've also got the policies, what's breaking, you know, so you can do what we call bear traps, which is essentially similar to tripwire, that suddenly in your OT to IT, that's the most common way to compromise your OT environment is through your IT. So suddenly you see something like a bear trap trigger to say, hang on, this policy's now changed. This ACL's done. Someone's running cert util on an OT device, right? That's an MRI machine that's running Windows XP, right? Because you can't update it because of, you know, the organization, right? So so when you start getting those contexts, you start getting those alerts and those detections all as one, then it allows you also to focus of hey, what should I do right now from an incident point of view? What should I do right now from a left of boom view as well?
Amazing. All right, let's take this to the real world. Now, I think we were talking off camera. I heard a number thrown around. You guys prevented maybe like $100 million, you know, incident. Yeah. Help me understand a little bit about, you know, like, you know, how you guys are you know, making you know, a major impact in some of these organizations.
Yeah. So that is, I can't go into details about that big defense contractor, but I can talk you through the process. We found Bluekeep early, right? And if you go to the Microsoft website for Bluekeep, you know, MS 2019 07 08, if you want to look it up. Microsoft have on the website what they had at that point in time. They had, it wasn't being exploited in the wild. There was no exploit available, and it had all those things that don't worry about it, patch it, right? So if you look at that, you know, we had it trigger one of our deception honeypots 10 days early, right? So before that CVE came out. So Michael, because a good friend of ours works there, and we were saying, hey, should we do this? Does this make sense? And Michael went on Showdown and looked at their address space and said, oh, they've got lots of Windows boxes, you know, on the internet, right? So a good friend of mine, we contact him, say, hey, you know, you need to do this right now, right? This is this. And, you know, at that stage, it was a you know, very motivated state actor that was after that company, which makes sense, right? And they quickly stopped all the connections for the internet for Windows until that patch came out, right? So, and they said that would be in an order of, you know, 100 million, right? So, and another one, like as I said, we said the Node one example was the whole business was driven on Node, and if Node compromised, the whole business would be under, right? Done in a day, right? So once again, we got ahead of that. That was once again, it was a Chinese APT group that you could update Node NPM version, and it would go to the internet if it had the same name and see if there's a higher version, and they would do a shimmy code that still ran the underlying code but compromised the whole environment. And we found that early in our whole process, in the intelligence collection and analysis process, using our own reasoning AI for that. So once again, it's, you know, if you're spending time listening and understanding the threat conversation, it puts you in a better position of, you know, what you should do and what we're seeing.
Yeah, that's amazing. And so, you know, I think we're getting towards the end of the session. You know, I'd love maybe, you know, a quick, you know, lesson from the field. Like, what are some of the lessons you learned in threat intel, and how others can apply them?
With the threat intel space, I think it's time for us to kind of move forward in what we've been doing. The process is very reactive. You know, your Kaspersky reports come out 3 to 5 months after the fact of the incident happening. They're amazing, great reports. People take a look and say, this is great. Let's look for in our environment. You know, we've had it 8 months in our environment now. It's time to move forward and, you know, go after the harder to get information. And that's the thing Andrew and I specifically said. You know, if we're going to start our own company, we're going to focus on the hardest intel to get, the most relevant and the most timely and accurate information. So I think as an industry as a whole, we need to move forward from just tracking bad domains, bad IPs, and malware hashes, and that's the way forward now.
All right. Now, if you could give, one piece of advice to a CISO building a proactive defense strategy, what would that be?
Understand what assets you have first. It's going to be key. It's baseline. If you don't know what you have, you can't protect your environment best. Once you have a good understanding of that, your actions based upon accurate information and timely information. Algorithms are good when you're far more mature in your environment. When you have good intelligence coming in, good context around the environment, that's when you start applying algorithms that are relevant, specifically built around that piece. That's the key piece there. And the third, I would say, is have processes, tools that can help you take that information in from the various types of context of the assets and information you're getting, and help you deduplicate that, help you build a process to get it to the right stakeholders, to get everybody involved to help defend against the environment, not just the security team.
Yeah, and I think today, in one sentence, sorry to interrupt, Thomas. The one sentence I'd say is, as you get more mature, use all the groups together. So if a new vulnerability comes on our list, then say to the detection team, what should we do? For the engineering team, is there something we can configure in the product? To the threat intel, what other threat intel we're seeing? From the SOC, are we seeing any anomalies already in that technology, right? And use that whole circle and getting value from all the people in the organization, right? And not just normally it's like an alert comes in to the SOC team and they deal with it, right? So if you start pulling everyone in those different parts, you can get ahead of the threat and you can stop those threats from now in the future, because then you understand what sort of weakness that is, right? So for example, you see a lot of people going to multi-factor authentication because we've finally said passwords, right, aren't the right way to do it, because we're always getting ATO attacks, right? So right. Doing that same process with those same common attacks in your environment puts you in a fantastic position.
Yeah. Gentlemen, thank you so much. It's been amazing. The founder story is awesome, and it's great to hear what you guys are doing with threat intelligence at Armis. So thank you so much.
Thank you, Tom, Michael, and Andrew. That was a great session. How many of you already use this approach in your asset management process? Share in the chat. Now, we'll take a short break, and when we return, we'll dive into a session on real-world implementations of continuous threat exposure management that are strengthening defenses across industries. You won't want to miss it. See you back here shortly.